The AppDynamics cluster agent monitors the health of Kubernetes and OpenShift clusters for all major Kubernetes distros, including EKS, AKS, GKE, and Rancher. The cluster agent collects metrics and metadata for the entire cluster, including every node and namespace down to the container level. Again, the cluster agent is a Kubernetes native application built in Golang and implemented using the controller pattern. The cluster agent watches for cluster events and observes all Kubernetes entities that have to do with pod deployments, services, replica sets, daemon sets, statement sets, and jobs. The cluster agent tracks resource consumption, network health, and configuration. This is a lightweight application with very low overhead. So let's drill into the servers and see what the cluster agent is showing us in the dashboard. So here we see the application pods. If we go to the cluster, we'll see the application pods that were deployed. AppDynamics monitors the load on each server and gives real-time stats like CPU, memory consumption, and other vital metrics. From the performance monitoring perspective, we can get a list of all containers, including all Kubernetes clusters managed by AppDynamics, observing the system's behavior from a Kubernetes perspective. Here in the dashboard, the agent just doesn't collect metrics, but groups metrics into categories to make it easy for the user to understand the origin of the user or the issue, whether the issue is coming from the application, a particular area of Kubernetes infrastructure, or the underlying host. Here we get a list of error events in the cluster, number of evicted pods, and the number of threats, all indications of a cluster meltdown. We'll also get visibility into cluster capacity, such as available memory, CPU, and maximum number of pods. And then we have several categories of errors as well as utilization. Pod restarts and crashes that typically point to a particular app issue. Also image and storage issues that may stem from misconfigurations, insufficient permissions, or quota violations. AppDynamics tracks CPU and storage utilization relative to the requests and limits declared in the deployment spec. These resource consumption metrics, like everything else in AppDynamics, are baselined, helping users define resource requests and limits for the application in a precise manner. When quotas are set, AppDynamics will track specific utilization of specific resources relative to quotas for memory, CPU, and storage. And users get alerted through health rules when any given quota is about to be filled, early enough to revisit capacity plans and quota allocations. If we go into the inventory tab, AppDynamics gives an overview of the cluster inventory, including the number of pods, namespaces, number of deployments, daemon sets with respective states. Note that the managed Kubernetes cluster on the public clouds do not provide access to master nodes, so the number of master nodes is shown as 0. On owned managed clusters, like this OpenShift cluster on AWS, we get the complete inventory of nodes, including the worker nodes. So AppDynamics also provides information on the violation of best practices, privileged pods, namespaces without quotas, pods without health probes, etc. One of the unique features of AppDynamics is tracking missing dependencies. For example, missing configuration maps or secrets that have been removed after the deployment. Another example is missing secrets that are supposed to route traffic to application pods. AppD also brings to light unused services, orphans, and other service endpoints with IPs in a not ready state. Now, if we go to the list of pods, and I'm going to concentrate on those, we can actually use the filtering function here if we wanted to actually identify the pod name, as well as any type of namespaces, container names, tags, things like that, pods that are running, and apply those filters, and then dive into that particular pod to see the pod detail. So this search capability gives us really quick capability to examine pod metadata, track resource consumption of containers in a pod. When a pod is restarting, pending, or over-consuming resources, users get visibility within the container, and we can investigate root cause. So we can see things like container usage, like CPU, memory, as well as other things. We also have a link up here at the top back to our APM world, and that takes us back to the application performance monitoring data, which is collected by the AppDynamics application agent. From here, users can examine the list of errors or do deeper analysis through transaction snapshots. This has been an overview of the Kubernetes cluster agent. Thanks for watching.